glad you brought it up. We got the ground surface. Drilled our well. Water table sits at a certain point down here. It's what we call the static water table. When nobody's pumping water, the water's going to sit at that level. Now, then we put a pump in here, and we start using the well. Now, the water still stands up here even though the pump's down here. It's got a lot of water. It's totally submerged. All kinds of water filling the pump, and we start using it to irrigate our lawn or the pasture or a potato field or whatever, and we start getting drawdown around the well. And as we pump it harder and harder, we get more drawdown, and harder, and we get more drawdown. And before you know it, we're operating down, and we end up with the water level drops clear down to here. This all been used up. And now we have to work harder to pump the water because we're having to push it further up. We've dropped the water table around the well. This thing's called the cone of depression. And this is our dynamic level in our pumpage. We've actually dropped the water table down to this point at the well site. Now the neighbor over here, his water level's still, its water table's still up here, see, if he isn't pumping. The static water table still sits high over on the sides, but right at around the well, and it could be a few feet, it could be a few hundred feet, it could be a quarter mile. Totally depends on how big the aquifer is, how porous the formation is, and so on, just how big that cone of depression gets. But in the process, it's also dropping the static water table a little bit too as we reduce flow if we're taking it out faster than it's recharging from upstream. So this static water table also could be dropping at the same time, and normally does slightly. And we call this differential in here drawdown. And we hear people talk about, well, my well had a drawdown of so many feet when I was pumping it. And what is normally the case is you want to test the drawdown after a 24-hour period. Run it continuously for 24 hours. Generally, it's going to find its stable drawdown point, generally speaking. And they test that at different times of the year. And in fact, they are monitoring in the test wells and also in all of the user wells in this valley. Many of the user wells have been selected according to location, so they're getting a grid of where the water table is sitting. The drawn down water table is sitting on these wells throughout the summer. So, and they're charting it and finding out how that water table is going up and down. And they're hoping it always keeps coming back up full every year and never drops too low during the summer. And there are wells that will draw clear down to where they start running out of water, Troy. And then you have this problem of pumping air and having a heck of a mess. Your solution is at that point shut off the pump and hopefully the well will recharge back up, see? If we drew this thing clear down to where it came clear down to here, then we got to shut the well off and hope this thing can build back up. Let it build back up before we turn the pump back on. I happen to have a hand-dug well out in my pasture at my house. It's only 12 feet deep. This is the super shallow aquifer. We're only a stone's throw from Yellowhawk Creek, and the water table sits about the level of Yellowhawk. Except in the summer, as we use that water in that neighborhood, it drops and drops and drops and drops, and it doesn't recharge very fast. There's always, if we shut it off, there's always standing water about 5 feet deep in that well. But I can run that well at about 12 gallons a minute for an hour and a half, and I will drain my sump totally dry, and I have to shut it off, and I have to wait about 10 hours for it to recharge to fill the sump again. It's not a very big sump. It's about 12 feet by 18 feet, something like that, and 5 feet deep. And so it takes a long time in the late summer and early fall to recharge that pit. All the rest of the year it runs great. In fact, now the water level is starting to come up in it. It's about 6 feet deep now. It's gained about a foot since the lowest point. And the lowest point happened about mid-October. That's when it gets its driest, before we ever started getting fall rains to start recharging that underground aquifer. But boy, it comes up in a hurry now. It's starting to really move again. It's coming right up. Yeah.
So Kona Depression is an area and the drawdown is the depth? Is that?
That's correct. That's correct. The drawdown is the actual vertical distance from the static water level down to where the pumping water level is at a given time. Yeah. And that's very dynamic. It changes constantly. And so does the water table level. In a lot of cases, the water table really moves around. Now, we have a house up on our farm on Mill Creek, and there's 3 wells within about a half of a mile distance on the creek area. And where my mother lives, we have a well. The water sits at 5 feet. And they pumped that thing at 700 gallons a minute, and it drew it down 6 inches. That's how good a well that was in August. That's how good a well that well was. Just a phenomenal well. But we're right in the channel of the creek there, and that's a very shallow aquifer. Water's just pouring down that corridor toward this valley. It's in the upper valley on Mill Creek, and it's very narrow up there. And that water's all being channeled into the center of that valley, not only in the stream, but also in the underground aquifer that runs in that particular area. The reason that valley got carved out is that's where the rock was the weakest and the poorest, the most porosity, and so there's lots of migration of underground water as well as surface water in that area. So that's kind of wells in a nutshell.